Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Different eras. Yeah.
Good afternoon, everyone, and welcome. Thanks for your patience. My name is Kim Ricketts, and I'm here to introduce and welcome Harold McGee, who is visiting us as part of the Microsoft Research Visiting Speaker Series and the Microsoft Chef Series. We're here together in the same room. Harold is here today to discuss his book, Keys to Good Cooking, a guide to making the best of food and recipes. In the confusing and often contradictory world of food safety, appliances, ingredients, and recipes, we can rely upon science to guide us from market to table. Long-held assumptions about cooking often fall away when examined and held up to scientific tests. Yet understanding this food science will lead directly to better, safer, and more delicious food. Harold writes about the science of food and cooking and is the author of the award-winning classic on food and cooking, The Science and Lore of the Kitchen. He writes a monthly column, The Curious Cook, for the New York Times. He has been named Food Writer of the Year by Bon Appetit magazine and to the Time 100, an annual list of the world's most influential people. Please join me in welcoming Harold McGee to Microsoft.
Thanks very much, Kim, and thanks for coming. So I have a new book out, and I'm on tour, and this is part of the tour. And so I thought what I would do is just talk for 10 or 15 minutes about how I got into this line of business, and a little bit about on food and cooking, the first book I did, and then how Keys to Good Cooking, the new one, is different. And then just have a conversation with you all for the rest of the time. Find out what you'd like to talk about. So I'm not a chemist and I'm not a cook. At least not a professional cook. And I'm not professionally trained in either one of them. What happened was I loved astronomy. And so I went to Caltech to study astronomy in 1969, and did that for several years, and after several years found myself spending way too much of my time standing in line to use the campus mainframe with my stack of punch cards, which usually had a hanging chad, which meant that I had to come back to do that assignment. And it just seemed to me that my interest in astronomy was waning because of the kinds of things that I needed to do in order to, at that time, be a professional astronomer. So that helped me realize that what I was interested in was more the ideas and the emotions that astronomy involved, thinking about those questions. So I decided to switch to philosophy and literature. Which I'd also been interested in. And I decided, this is not the place to study those things, so I'll apply for transfer. And I asked my teachers, Caltech does have professors of English and history and philosophy in order to give an accredited degree. And I told them, loved your courses, I'm going to kind of follow up on this. Please give me letters of recommendation so that I can go to Stanford or someplace like that. And they said, no. We don't have any students, so we want you to stay. And they said, if you stay, because you're here because you love science, and that hasn't changed. You stay here, we'll have classes where you'll be the only student, and there'll be a couple of us. And we'll give you the best education in literature and philosophy that you could ask for. And what they didn't mention, but which turned out to be the best part of the deal, was I then was able to cherry pick the science courses. I wasn't locked into applied math 95 and all that kind of stuff. I could take anything I wanted, and I did. And that turned out to be a great preparation for writing about food, because it seems to me that you can illuminate food from almost any scientific discipline, astronomy included. So I stayed and got a Bachelor of Science degree in literature, from Caltech, and then went on, got a PhD, and wrote a thesis whose title was Keats and the Progress of Taste. But this was literary taste rather than literal taste. And taught for a few years, but I wasn't able to get a tenure-track job. And after a few years of these year-to-year contracts, that got kind of old. And I thought, well, I've been teaching writing among other things, and so I think I'm going to give this up for a year and try to write, see if I can make a living doing that. And I thought I would recoup my interest and my investment in science by writing about science. So I looked around, and, well, astronomy was being covered by Stephen Hawking, and biology and medicine by Lewis Thomas. I don't know if any of you remember him. He was a remarkable essayist. So those examples discouraged me from the bigger, more prestigious subjects, and I instead thought, it'd be kind of interesting to look at the science of everyday life, the kinds of things that are happening all around us all the time that we just don't think to look past the surface of. And weather is interesting, and geology is interesting, all kinds of things are interesting, but I settled on food for a couple of reasons. One was that it's the place where we interact with natural materials and actually do things to them, make a difference with them. With the weather, we just suffer it. We observe it, and that's about it. With food, we can actually do things, and fun things, creative things, and experiment. So I thought that was one big advantage. I also was getting interested in cooking. I'm now in my mid to late 20s and getting more interested in that kind of thing, and wine. And then what really did it for me was a very particular question from a friend of mine who was from New Orleans, a Coleridge scholar who loved red beans and rice. And so I was just talking about this idea of writing about the science of cooking one day. And he said, okay, if you're going to write about the science of cooking, I've got a question for you. He said, my favorite food is red beans and rice, and my problem with my favorite food is I can only have a little bit of it, otherwise I suffer. And so I want to know why it is that red beans give me gas, and I want to know, is there anything I can do about that? Are there other beans that are less troublesome? Could I replace with those? And this was right about the same time that Blazing Saddles came out. So it was a topical question. And I went to the library for the first time really to delve into the food science literature to see if that kind of information was available. I thought it was a very good question and fun. And discovered on that trip to the library the TX section of the Library of Congress system, which I'd never been in before, and which is was just this undiscovered treasure trove of arcane information about foods and food preparation processes that had been developed for industry, but never translated for restaurant cooks, home cooks, just ordinary people who are interested in food. So I knew that I'd found something that I could spend a couple of years on and do something interesting with. I also found the answer to my friend's question, which was great. But beyond that, I found that most of the research on the subject had been funded by NASA. And if you think about it, it makes a lot of sense. And that made me realize, and my publisher then reinforced this idea that just as interesting as the facts are how we come to know the facts and how they connect with other things in the world. So that's how I came to write on food and cooking. And I had the idea in the late 70s. It was a time when Americans were beginning to get really interested in food, but the food revolution had not really begun. So I was just very luckily placed to take advantage of that as it developed. I wrote the book on an electric typewriter. I did research for the book by going to libraries and finding the index volumes of poultry science and cereal chemistry, and looking to see if anyone had addressed the issue of whatever over 10 years, and if not, then I gave up because I couldn't spend all my time on that particular question. It was a very inefficient way to do research, and the information was pretty sparse. So then, 20 years later, when the second edition came out, the red volume, the problem was actually the reverse. Now we had computers and the internet, and there was too much information. And I would go to UC Davis, which has a great food science department, and essentially immerse myself in the subject for a week, stay at a hotel and be at the library all day, and then take all the stuff that I was able to find out home with me and turn it into a chapter. So that's the story of On Food and Cooking. Keys to Good Cooking, the new one, came about because a lot of professional and home cooks who like On Food and Cooking also told me the problem with this book is that if I have a particular problem in the kitchen, it takes me way too long to find the answer because there's all this other stuff in there. It's not just practical information, it's where these things came from and how other cultures use them, and interesting to know, but not helpful in the kitchen. On Food and Cooking is a book that's meant to be read in a chair, sitting down and reading sections at a time. Keys to Good Cooking is meant to be used in the kitchen to answer questions in the course of cooking. So it's a reference book about techniques, ingredients, problems, best ways to do things, worst ways to do things, so that if you're picking a recipe or you've got a recipe and it's leading you down the wrong path and you know that, or if it's Thanksgiving and you haven't cooked a turkey for a year and you want to remind yourself what that involves and what are the pros and cons of brining and stuffing and all that kind of thing, that's what's in this book. No recipes, but lots of information to help you work with recipes. It's a very interesting time in the food and cooking world, because when I started writing about the science of food and cooking, people generally thought it was a strange idea. And any kind of press I got was sort of the mad scientist approach. What's this crazy guy doing? But now it's become fashionable, and there are TV shows about it, and every magazine and recipe book will include sidebars about what's happening to the protein molecules when you're doing this and doing that. And of course, there's experimental cooking, the kind of thing that Nathan Myhrvold is about to publish a magnum opus on. Along with all that has come a lot of misinformation or just bad information, because it's now a fashionable subject. Everybody's getting into the act, and people are saying molecules do this and that just in order to be able to use the word molecules. And so there is a lot of misleading information out there, and that's, again, part of the reason I thought it would be useful to have a book that does nothing but talk about that kind of thing, so that you don't have to take it on faith that this particular recipe for pasta is giving you the real deal on starch. Anyway, that's how I came to do this. That's what Keys to Good Cooking is all about, and now I'd be happy to talk about whatever you'd like to talk about. Yes?
I recently acquired a incredibly convenient recipe for making pumpkin custard, which I've now made like 5 or 6 times back to back because it keeps running out. And it doesn't follow what you describe in On Food and Cooking as the way to make custard at all, and so I thought I'd ask, why does it work? It just consists of taking a can of pumpkin puree and 16 ounces of cottage cheese or yogurt, 4 eggs, some sugar, some cinnamon, mix it up put it in ramekins, toss it in the oven for half an hour, you're done. No slow cooking over the stove, adding the hot milk to the meat. None of that. Just incredibly easy, which I like, mind you.
Yeah. Well, what I would say is that's not a custard. And I would make the general statement that there are lots and lots of different routes to the same basic end result. I mean, the different routes will get you to slightly different places, but usually if someone tells you this is the only way to get the perfect X, you know not to trust them, because there's no such thing as the perfect way to get to X. But that's a recipe that a custard is egg setting liquid, and the fact that you start with concentrated pumpkin or sweet potato puree, that's starch. You're making a pudding, not a custard. And puddings are very easy to make. There's no risk of the egg proteins curdling because they've been protected by all the starch that comes from the pumpkin. So, but it sounds delicious. Yes?
You committed a good part of your life to food, but you're thin. Outside of dating you, how do you do that?
That's genetics. Yeah, both my parents are like this, and I think I'm a very inefficient metabolizer, is what it comes down to. I love to eat. I eat everything. My blood lipids are not great, so that at least shows what it is that I'm eating. But yeah, the fact that this happens is my parents. And I wish, so many people early on, especially when this was a weird approach to cooking, people would look at me and say, "You don't like to eat, do you? You don't really like the subject. You're a scientist. You don't like it." And so I wish that I could kind of, go into a phone booth and whiz around a couple of times and turned into James Beard. 300 pounds, jolly mustache. Yeah.
How much testing and experimentation goes into your process of coming up with these principles versus just research?
I do a lot of testing and cooking in the kitchen because I learned early on that what passes for fact in a food science textbook or a journal often doesn't bear directly or even at all on what happens, on a smaller scale in a kitchen. And also, I learned very early on that I could, knowing chemistry is wonderful, but foods are so complicated that knowing chemistry doesn't really tell you much when it comes to predicting what's going to happen with a particular system. You have to do the experiment in order to be sure. You can have educated guesses, but I've been wrong so many times that I always have to do it before I believe myself. So a lot. Yeah. Yes?
Now, Cook's Magazine is a fairly popular magazine, and quite often his articles start out by saying, "I wanted to make the perfect custard," and like he's saying, sort of a science fair experiment. I'd be interested in your thoughts or impression of Cook's Magazine, and also Kitchen Science, which is a popular book that I have. So those documents, so what do you think?
Okay. Kitchen Science.
Quality of science in Cook's Magazine.
No, I feel with cooks, my problem with cooks, I think they do, what they do very well, but what they do is not what I would do. And what they do is to kind of predefine what a thing should be, and then say that the thing that gets them to that easiest and quickest is the perfect way to do it. And I actually don't read it that much anymore because so many times I've felt that it's leaving out so much about a particular ingredient or a particular dish that it's picking its definitions pretty narrowly. But that said, if it is a way to kind of gradually accumulate a good amount of understanding about how things work. So I think in that sense it's a valuable contribution. And then Kitchen Science is that a book that you're by?
Sorry, about 20 years old. Maybe.
Okay, Peter Barham, maybe, kind of thin,
Right.
or Howard Hillman, or
That's the one.
yeah. That's a kind of Q&A book. So it answers specific questions, and it's good. But if you don't happen to have that question, or if you have a question that's not in the book, then it's not so helpful. Yeah. Yes.
I think one of the things you've written about is like differences among people of sensitivity to cilantro or the smell of whatever it is in urine after eating asparagus. And there's one that I don't think you addressed I've been wondering about. So I'm a foodie, spend all my time, money, cooking. I want to be able to taste truffles and have that whatever experience people describe and pity and mock those who can't. But nothing wrong with them, but I just don't get anything from them. Is there a difference there?
Yeah. So I was at a meeting, the meetings that gave us the unfortunate term molecular gastronomy back in the 90s. There was a meeting at which the subject was taste and smell, and one of the speakers was the director of the Monell Chemical Senses Center in Philadelphia. And if you have any interest in taste and smell, you should check out their website every once in a while, because they do wonderful work there. They've got amazing people working there. So he came and he gave a talk about various things, among them the characteristic smell of black truffles in particular. And is it black truffles rather than white?
The only thing that I get is the truffle oil, which is, I'm sure, completely artificial in some lab that made me like it.
Yeah, exactly. So it's black truffles that have a particular compound in them. It's a steroid, androstenone, which is what attracts pigs. That's why pigs are good hunters for them, because it's a component of the pheromone that males make for females. So you take female pigs out and find truffles that way. So when they figured out that was the major component of the aroma, they then began to study it, and because it's also found in some human secretions, they began to study human responses to it, and they found that a lot of people can't detect it. And so that actually became a demonstration at Monell. They would, if you came to do a tour, they would give you a sample and ask you to smell it, and they were actually taking statistics. Can you smell it? And isn't it interesting that some of us can smell it, some of us can't, and that kind of thing. The guy who was giving the tour most often couldn't smell it. But after a few months of giving the tour, he started to smell it. And so what that indicates is that sometimes we may have receptors for things that are expressed in very low numbers, not high enough that we'll actually be able to register them, but that with repeated exposure, there's some mechanism that multiplies those receptors to the point that you can actually detect them. So Gary gave this talk at RHA to explain this, and there was a chef, French chef, 3-star chef, Pierre Gagnaire, no less, who was there, and this test tube was passed around. He couldn't smell it. French 3-star chef can't smell truffles. So it happens to the best of us, but if you'd like to work on it, you can work on it. Yeah.
I'm wondering if you've ever tried a new wave oven. We just got one of these. It's like a convection infrared, kind of a desk, a countertop cooking unit. Wondering if you've tried anything like that.
No. New wave is what it's called? Yeah. Convection and microwave and...
It's convection infrared and maybe something else.
Oh, infrared as well.
Yeah.
Okay. So it's so it's got a halogen.
Last night it came out of Pringles.
Yeah. So these have been around for, I'd say, about 10 years or so, and there was a big launch of them about 10 years ago, and then they disappeared. I guess they were too expensive or something, but they maybe their time is coming. I think there's a lot to be said for them, because there are lots of ways to get energy into foods, and different things get energy into different depths or at different rates, and that can be really useful for kind of fine-tuning the cooking of meats especially. But I don't know that particular one. I'll have to get one and start playing. Yes?
think you saw this on an episode of Top Chef when they were one of the challenges was to do something with lobster, and one of the contestants boiled the lobster, and she put a cork, like a wine bottle cork or a champagne cork, in the water with the lobster, and she said this is an old trick to, and it helps keep the lobster meat tender, right? And that just totally didn't make any sense to me. So I was wondering if there's any actual basis in fact, or was she just a little wives' tale thing?
Yeah. It seems to me that it's a little old Italian chef's tale. That's because it's a very common thing that's said about cooking octopus. If you're going to stew octopus, that you should have a wine cork in the liquid. So I was actually working in the kitchens one day at the French Laundry down in California, and it's still remarkable to me that this kind of thing goes on in a kitchen of that caliber. But I was there to kind of answer questions, talk with people, and this question came up. There was a chef from Italy. They were making octopus, who said, "Why aren't you putting corks in the water?" And they said, "Why would we put corks in the water?" And he explained, and everybody looked at me, and I said, "I can't think of what it could possibly do. The reason corks are valuable as wine stoppers is that they're inert, that they don't destroy the wine." So, but I said, "I've never done the experiment." And so Thomas Keller said, "Go ahead, do the experiment." So we did 2 pots side by side, one with corks, one without. The first thing we noticed when we threw a cork in was, of course, it floats, which means that there's like a square millimeter of surface contact with the water. So we thought, that's not going to do anything, so let's put a bunch of corks in there. And so it was like 20 corks, and we weighed them down with a plate so we'd maximize the contact. And then we cooked them the same length of time, and then divided them up, put them in the back, and had people come along and taste them side by side. And nobody could tell a difference, except that one tasted a little woody. So I think the lobster thing has been borrowed from the octopus world.
It may have been octopus too.
Okay, yeah, I bet it was, because lobster doesn't need any help really in being tender, except avoiding overcooking it. So. Anyway, yes?
I used to go camping a lot, and I had a friend that claimed that, getting coffee when you're up in the high altitudes is a chore. So he claimed that he could boil water, just throw coffee grounds into the boiling water, brew coffee, and then by throwing eggshells into the mix, it would cause the coffee grounds to precipitate to the bottom.
Uh-huh. And
I'm wondering if that's true, and if it is true, why that is.
Yeah. Well, in fact, a lot of older coffee recipes call for exactly that. If you look at 19th century recipes, they'll often call for that. And I think it's the residual egg white on the eggshell that does it, and not the eggshell itself. Because it's essentially using the same principle that's used in fining wines and in clarifying stocks. The proteins just attract and hold on to particles of various kinds and form a kind of clot that takes them out. So, yeah. Yes?
I'm curious, like with the Italian chef at the French Laundry, what kinds of responses do people get when you sort of pierce these long-held, cherished beliefs about my grandmother's silver spoon and whatever?
Yeah. For the most part these days, acceptance. And the best example of that in my recent work is this column I did for the Times about pasta, where one day I was doing the usual thing, boiling 8 quarts of water in order to cook 1 pound of pasta. It takes like half an hour to bring the water up, and then you cook for 15 minutes, and then I'm pouring all the water and the energy down the drain, getting steam on my glasses, I can't see anything, and wondering, why am I doing this? So I tried starting with cold water, and pasta, cold water, cold pan, turn on the heat, and just enough water to cover the pasta, kind of like rice or something like that. And all the books say it's going to come out gummy and sticky and so on. It didn't. It came out delicious. And the cooking liquid did get very thick, but it was thick in the way that a sauce is thick and had a wonderful pasta flavor. So I presented this to my editor, and he said, okay, that's great. Call Marcella Hazan and call Lydia Bastianic and get them to comment on this, because it's contrary to anything they've ever written or done. And so I did that and was shocked at the result. They both said, that's interesting, let me give it a try and I'll get back to you. And they both tried it, got back to me and said, both of them in their own ways, you know, that's not so bad. I still prefer mine, but thank you for checking that kind of thing out. I thought I was going to get exactly what you, yeah. So, yeah, I think people are much more open to the possibility these days that there are more than one route to the same goal, and it's worth knowing about them. Yeah. There's a question back there. Yeah.
So I have both of your books, and I haven't read them all yet. But I'm petrified that after this lecture I'll go home and I will have a question to which your books will not have an answer to. And then where do I go?
I guarantee you that that's going to happen. And that's part of the point, actually. If I can get you to be thinking about food in such a way that you end up with more questions than answers, I think that's a good thing. And I would say for a lot of time, for a lot of things, the place to go for an answer that you don't find in the book is into the kitchen to do an experiment and to see what happens. I get a lot of questions where people will ask me, what will happen if I do X? And my response is, do it and find out. Because there is still so much, I think, just to observe from doing side-by-side comparisons, you know, an experiment and a control. That's why I love birds, by the way. I'm getting a little tired of Thanksgiving stuff at this point, but birds are wonderful because they're bilaterally symmetrical. So you can do one thing to one side, something else to the other side, stick it in the same oven, all set. Yes?
Can you comment on the belief that reheating food in a microwave in plastic affects the food at a molecular level?
Reheating, microwaving food when the food comes in contact with plastic wrap is generally advised against, because plasticizers in the wrap can end up migrating into the food at those high temperatures. And that's not in general a desirable thing, to have these unknown and foreign materials in our foods. Now I think it's much less of an issue these days because the formerly nasty but really useful plastic wraps like Saran and PVC, Saran, and I discovered this the hard way by doing a demonstration that failed. Saran has been reformulated. It's now just polyethylene, but it used to be polyvinylidene chloride, which was a really, really good oxygen barrier. It was the best plastic wrap. But it's environmentally unfriendly, and you didn't want to heat with it because some stuff could leach into the food, and that wouldn't be good. Polyethylene doesn't have much of that, so it's much less of an issue with polyethylene, but I still think, you know, on the precautionary principle, and there's no need for it to be the case. When I warm something up in the microwave, I have it in a glass or a ceramic bowl, and I just put a plate on top of it. And then you don't have to worry about it. Yes?
So what do you think about the whole sous vide thing? Because like I have a friend who is really into gadgets. And he went and he got an immersion circulator, which his girlfriend calls a bucket with a thing. And he got the vacuum sealer. And he's proceeded to make all sorts of things, you know, at precise sous vide temperatures. And he did these ribs at 120 degrees Fahrenheit. And I look at that and I think, oh my God, from a food safety perspective, is this a problem? So I'm sort of wondering, are these going to come into our kitchens? And when they do, is there going to be like a mass epidemic of, you know, people having problems from food that's not heated enough?
Yeah, good question. So sous vide is French for under vacuum, and it refers to the vacuum packing part of it, which is putting foods into plastic so that when you then put them into this very well-controlled water bath, they're not exposed to the water. So to me, that's kind of getting things backwards, because the important thing about the technique isn't the wrapping, it's the temperature control. And so I prefer to talk about low temperature or precise temperature control cooking. And in a way, it's kind of amazing that it's taken this long for cooks to have access to that kind of control. I mean, it's been in laboratories for decades. And cooking is essentially taking ingredients and transforming them with heat. And if you don't have control over the heat, it can be dicey. That's why I think so many things don't come out so well. So, especially for meat and fish, I think it's a wonderful thing. If people are cooking things at 120 degrees, then yeah, that's a problem, because that's right at the cusp of bacteria having a really great time and bacteria beginning to die off. And you don't want to be up there. But the books that have come out on the subject, and Nathan's will be another amazing tome. I think there will be pretty much a whole volume devoted just to that technique. The rules are pretty clear about the temperatures and the times and so on. And if people follow the rules, everything will be fine. If people don't follow the rules, then there could be problems. Fortunately, I think most 120 is pretty low even for rare meat. So if you get it up to 130, 135, it's still pretty rare, and that's a good temperature for killing bacteria. It just takes a longer time to do so.
Washington kind of says 140 if you do any sort of commercial food service.
Yeah, and that really comes from federal standards, which have been creeping down over the years, and so we're all learning. It's because it is a new situation to have so many people using it. Yeah.
So you made reference to the sort of the pop food scientists, and I'm thinking like Alton Brown on the Food Network and stuff. But they have introduced a lot of people and a lot of interest in science of food and cooking, and why does my cookie come out better when I do this, or the creamy is different. Have you been approached about doing anything, or thought about doing any specials or television programs?
Well, I've done the odd thing here and there. In fact, just this morning, I was on Martha Stewart. Still not quite sure what to think about that. No, it was excellent. It was excellent. Very good questions, and questions that were important to a lot of people. But I was surprised to be there, surprised to be asked.
It certainly seems there's enough material and enough demonstrations and live labs that can be done that make an interesting program.
Oh yeah. And I think actually Alton Brown does a great job. To me, he's an educator. He's found a way to take material like this and make it interesting and appealing, something that you can watch for an hour and you remember it because he's made it so much fun. So I think he does great work. And he's also kind enough to start some of the episodes by showing him sitting in a hammock reading my book and then putting it down and then getting on with the show. So anyway, he's a good guy.
So are we going to see you on Food Network?
That I don't know. I think Food Network especially, you have to have a certain personality, I think, to,
Be the next Rachel Ray.
Got to work on my bubbliness, I think. Anyway, yes.
So what advice would you give to people who might be interested in pursuing a career in food science?
Advice for people interested in pursuing food science. I think it's a really interesting time to be going into food science right now, because 10 or 15 years ago, the career path was pretty direct from school to craft. That was really about it. Or to an academic position where you would then get funds from craft to work on processed cheese. But one of the interesting things that's happened in this kind of the way food science has become fashionable is that food scientists have realized that their subject is sexier than they knew. But it's only interesting to more people if they address issues that are of interest to more people. And a number of restaurants these days actually have established semi-formal collaborations with food scientists. The best example of this is Heston Blumenthal in England, who has a relationship with the food chemistry department at Reading, and then the sensory psychology department at Oxford, and another group up in the north somewhere. So a flavor group at Nottingham. And so these people all come down to the restaurant every once in a while, and he has a research and development kitchen as well as his restaurant kitchen. And the R&D kitchen is there essentially to come up with new ideas and better understanding of things. And I'm sorry?
Oh, El Bulli have that as well?
El Bulli has that as well, yeah. And a number of restaurants now. I mean, maybe not as formal or with as many people involved, but so I think that's going to happen more and more. And on the other side, the food companies are realizing that these chefs know something about what makes foods delicious that will be worth their knowing too. And food scientists are going to be the people who will help translate what it is that chefs have learned to do over the course of thousands of years, and find ways of making mass-produced foods better. So I think there are opportunities in the restaurant world and in the manufacturing world that didn't exist before. So it's a good time, and there's some good programs. UC Davis, Rutgers, Illinois, UMass, lots of good programs. Yes?
When you make mashed potatoes, do you boil them whole with the skin still on and then try to get the skin off when they're raging hot? I've read that a few times, but it just is too difficult.
Yeah. No, I don't do that. I pre-peel, I steam them. I use steam a lot because it's a way of using, again, less water, less energy, less time. It's a lot faster. And steam other things in there as well at the same time, garlic and celery and things like that, and then just mash them up together. Yeah. Yes?
I'm always surprised at recipes that use whole numbers for things. Like, why does the cake take 3 eggs rather than 2.7 egg whites and 2.4 egg yolks? Why are recipes so flexible in this way?
Well, if you think about how anyone would ever have tried it with fractional whites and yolks, you got a whole egg, you're going to throw in a whole egg, or maybe you'll separate it into whites or yolks, or throw in 3 whites for 2 yolks, or something like that. But I think when it comes to cakes and breads and things like that, there is a tremendous amount of flexibility, and you can make fairly substantial changes in proportions of the major ingredients and still have it come out palatable. They'll be different, but they'll still be palatable. And then it becomes a question of, what exactly are you aiming for? What is your definition of perfection for a layer cake or something like that? And if it's worth measuring out fractional yolks and whites, then that's what you'll do. Otherwise, you'll take the easy way and just use whole measures. But I think it is true that a lot of ideas about desirable proportions are very arbitrary. And an example I'll give you is mayonnaise, which I've written about, where classic recipes say that in order to emulsify 1 cup of oil, you need 1 egg yolk. And that's pretty suspicious sounding, right? So when I read that and thought about it, I thought, that is probably arbitrary. I'm going to see how many cups of oil you really can emulsify with 1 egg yolk. And the answer was quarts. Not 2 cups or 3 cups, but quarts. Again, I think what happens is that people find a set of proportions or a method that works, and then they say, this is the way to do it. When in fact it's just one way. Yes?
As an appetizer, would you describe 1 or 2 topics that I would find in your book, in your new book?
Okay. Well, there is a whole chapter on food safety, since that question was raised. I think it should be an issue not just for people doing sous vide cooking, but for anybody who cooks for other people. And the way people take care of or don't take care of leftovers, I think, is a place where we would have many better next mornings than we do now if people took more care with that. Didn't quite relax after dinner until they'd put things away rather than letting them sit out for a long time. So that chapter tries to essentially summarize what's going on in a kitchen, what microbes are there, how do they persist, what can you do about them, can you live with them, those sorts of issues, as well as specific things to do if you're dealing with people who are ill, that kind of thing. So that's one example. And then the other things are, again, basic advice about everyday techniques and everyday dishes, but pointing out that there is more than one way to get to the same thing. So I don't think you'll find the pasta idea in a cookbook. And I don't think you'll find the mayonnaise, the fact that you don't have to worry about how many egg yolks you've got, in a cookbook. So those sorts of things are what it brings.
Maybe two more questions.
Okay. Let's see. I see. How about people who haven't had a chance to ask a question yet? Okay.
So I know you said that there's many paths to get to the same ending, but Thanksgiving's next week. You found to be like a pretty straightforward, simple, great way to get a great turkey. What would be your first choice after all the experimenting?
I would say, if that's what you want, cut it up into breast and leg and cook them separately. And if that's acceptable, it works great. If you want to present a whole bird, then it really is a challenge, because you've got these two different kinds of meat that need to be cooked to different temperatures, and they're on the same bird in the same oven. If presentation is less of an issue, then definitely cook them separately and cook the breast to 150 and the legs to 165 or 170. And get a nice digital thermometer, not the so-called instant read dial thermometers that are unreliable. If you're going to do the whole bird, then the thing that I like to do, although it still doesn't absolve you of really paying close attention, is to take the bird out a few hours ahead of time and ice the breasts down while the legs warm up to room temperature. And then the bird goes into the oven with a temperature differential built in. And if you catch the breast at just the right moment, it's good. But you still have to monitor it. Okay, in the way back.
Well, this is a question for my own sanity. My boyfriend has been obsessed with making stock for the last month. He's an engineer, so he's extremely precise. And I'm not a foodie. I'm a foodie that definitely I enjoy food, but I'm not precise when I'm cooking. Do you have any advice?
About how to live with him?
On how to give him tips for the stock. I tried like the last 5 that he made, and to me it's absolutely delicious. But he's not happy with it. He's like, there's something missing.
Something missing. And are these beef stocks or veal or chicken?
Chicken.
Chicken, okay. Has he tried the pressure cooker?
No.
There you go. So brown the bones in the oven, along with some vegetables, carrots and onions and things like that. Put all the stuff in a pressure cooker and cook for about 40 minutes. And the great thing about the pressure cooker is, because he says something's missing, when you're cooking a stock in the traditional way, the kitchen smells great, and that's because all this aroma is coming out of the stock. In a pressure cooker, it's retained, doesn't go anywhere. And so he may find that that gives him a more concentrated flavor.
So put everything in the oven for 40 minutes. Just the bones?
Yeah, brown things. Well, that's actually a matter of taste. Some people prefer to make what's called a white stock, where you haven't pre-browned. But for the most flavor, for the biggest flavor, what you want to do is brown it first.
Okay, thank you.
Okay, good.
Thank you.